Hi, it's Alex from Inside Gadgets. Today we're going to be looking at, in some cases, how using all the SRAM can lead to problems, such as the SRAM being overridden by the stack pointer. I've just got just a sample memory test program. It doesn't quite matter what it's doing, it's just more important the results that we encounter. So right now it's just we've got a variable test. It's got one's enough to fill up all the SRAM, so it's 100% full. And now we're going to briefly just switch over to the data sheet and just have a look at what the stack pointer function is. The stack pointer points to the stack, and the stack is used for storing data such as local variables and return addresses. So whenever you enter in a subroutine or an interrupt, and the compiler thinks that you're going to use that variable after the subroutine or interrupt, it will actually store that on the stack. And it also stores the return address. So after the subroutine or interrupt, it will know where to return to. So when you see a push command, that's when it's actually putting things onto the stack, and the pop command is when it's taking things off the stack. Let's jump over to AVR Studio, where we'll open up the decompiled hex file, and let's open project, select the hex file, and we've got it up at the moment. So this is the code that's been run by the AVR. We're going to be having a look at this stack pointer, and this is where the actual program memory is. We'll change that to data, which is the actual SRAM. So it's got 128 bytes of SRAM for the 80tiny25, and here we've got the registers. So we can start debugging. We'll just start stepping into executing one by one. So you can, at the moment, before we go any further, we can see the stack pointer points to DF, which is the last byte of the SRAM. And so we'll hit F11 a couple of times and we'll see it start loading up the ones which were from our test variable. And so we'll load up 124 of those. So what I'll do is I'll insert a breakpoint here, and then we can hit F5 to run until that breakpoint. And now we'll start pressing F11. So we're going to jump into a subroutine. And before we do that, you'll see the stack pointer change, and this should also change as well. So 1F. Now we're going to be pushing the register R28, which is DF, onto the stack, and the stack pointer is pointing to DD. So DD is currently 60. So when I press F11, that will change to DF, and it does. And the next thing we're going to be pushing on is R29, which is 00, and then this will also change. So right now it's DC, and it's going to be pushed back, and now it's DB. So the next thing, if we put anything on the stack, it will be on DB, and that will override some of our ones. So we'll keep pressing F11, and right now we just jumped to a subroutine. You can see the stack pointer changed to D9, so we're actually at over here, D9, and it's just overwritten 2 of our 2 bytes, which is 2 of our 1. So right now we've just experienced the stack pointer overriding our variable in the SRAM. So I've just brought us back to before we jumped into the subroutine, so we can just do a bit more of an analysis of what's going on. So right now we're at 4F, and the next address is 50. So when I press F11, it's going to jump to the subroutine, and the stack pointer is showing as DB. So it will change DB to read 50, which is the next address that it has to go to when it's come back from the subroutine, and DA will just be 00. So I'll press F11 now, and we can see it's changed to 50 and 00, and the stack pointer is now increased to D9. So I'll hit F11 a couple more times until we jump back to 50, at which time we'll see the stack pointer jump back up to DB. So now we've jumped back to 50. the stack pointer's gone to DB, and you can see it's actually left all the information, the 50 and 00. If you do notice any weird problems with your AVR, such as variables changing, the first thing I would try is to reduce the SRAM usage that you're using, and also try to disassemble the hex file like I've done here. Thanks for watching.